We start now. So this is the practical lecture. Maybe the first practical lecture after the briefing that I've done last week. So in this practical lecture, I will cover multisim. I will do multisim first for this week, and then maybe next week on Thursday, another meeting, we will explore on how to use the LT-Spice, which is there is two software. Two software that are related to the circuit design, which is Multisim and LT-Spice, covered in this course. So the other software, which is AutoCAD, it's much more to the design of the cabinet, in which we will cover it later, maybe in our last part of our practical lecture, because I am planning to do Multisim today, and then LT-Spice Thursday next week. And maybe after Thursday next week, after Thursday next week, it's already break, right? It's already midterm break, starting from 27. Right? So we have this week and next week to cover some of the practical modules that we have. Okay, I will from time to time announce in your WhatsApp group and also in eLearn about our planning on the practical lecture. Okay, but for the theoretical lecture, it will happen as usual. So we'll do the theoretical lecture as well as usual. Our session on Monday from 5 o'clock, right? So today we are going to focus on multisim. As you can see, this slide has been shared with all of you. I hope that you can have a look at this slide from your PC, and at the same time, for those who have already installed Multisim, make sure that you can do it at home, right? So what I'm going to do today is to do the demonstration from my PC while we go through all of these slides that I've prepared here. So we'll go through all of these slides while doing the practical, which is design of our circuit and also simulate the circuit using multisim, right? So multisim, all right. So for the multisim, the objective for software, the objective for this practical one lecture, which is about multisim software. I hope that the student will be able to learn how to draw a schematic diagram of a circuit, meaning that from scratch, okay, from scratch, you can start finding the components, okay, identify which component you like to place, and then try to do the connections, do the wiring, the connection for each of the component, and then put the source, for example, put the loads, okay, make some labels, all right. Then after that, you can do simulation to test the circuit and do some analysis to the result of the simulation that you have. Okay, so basically to learn something lah from that simulation software like Multisim. The second one, to learn software application. Okay, the second one is more to the application in designing electronic equipment. For example, you can use this Multisim to infer or to reconstruct the circuit. For example, I have given you the mini project. Okay, I have given the circuit design of the line following robot from my hand sketch. Okay, from my handwriting. Then from that, you can resimulate or redraw that circuit using Multisim software, and then do simulation to study about that circuit, right? That is means by learning software application. Learn software application, meaning that we have already had some circuit, okay, let's say we get a circuit from the Google, for example, for the amplifier circuit or filter circuit, whatsoever circuit, then you like to do it in this simulation software. That you want to rebuild this circuit. The first one is more to do it from scratch. All right. Okay. This one is much more to we transfer the circuit from outside source, and then we do the simulation or circuit design using this software. And then the third one is to perform simulation. So we want to do simulation of the circuit, and we want to see the output from the simulation, then do some analysis about the output. So basically the same thing we can do in our lab, which is the hands-on or practical one. Instead of using the software to do the simulation, we can use the same setup at the lab. For example, if we have some components, capacitor, resistor, source, okay, programmable source, DC source or AC source at the lab, then we can do the same thing, do the connection and so on, and then use the oscilloscope. At the lab, we have the oscilloscope, and then we can learn how to use that oscilloscope to observe the output, right? So in this case, we are trying to do it using software, which is the same thing. Okay, so the learning outcome, which reflect to each of the objectives set in this study. The first one, ability to draw an electronic circuit, which is reflect to the first objective. This one is learn how to draw. But in terms of learning outcome, okay, as you can see, the sentence is quite different, which is ability to draw, meaning that you have acquired that knowledge, okay. And then ability to understand and infer, okay, understand the circuit from outside source, for example, then try to rebuild this circuit using this software, okay. Then ability to do simulation and do the analysis as well. Okay, so next is the introduction of the multisim. Okay, I think all of you already know that multisim is one of the product that is provided by National Instrument. Okay, National Instrument is based in US, United States, and the version of the multisim is now 14.2. If you have a check at the NI National Instrument website, basically they have started multisim since a few years, since more than 10 years, I guess. So this version is now 14.2, and then actually they are selling this license for about, I think, around 3,000 per year. The cost of full version of multisim is about 3,000. Okay, and from National Instrument also there is another software, which is Labview. Labview is another software from National Instrument, which costs about more than 10,000 per year. I think in UMT uh, we have no software like Labview, which is more advanced software. Not just by using simulation in the PC, but Labview is much more. We can control the outside source. Okay, like for example, we have the electrical machine or motor, DC motor. Then we can connect the DC motor to the computer and do the simulation in using the Labview. Okay, so that sort of thing the Labview can do for us. Compared to Multisim is just software for doing everything in using computer, just to do the simulation, not integrate it with the hardware. Okay, so basically Multisim is one of the software that works based on SPICE. Okay, SPICE simulation. So SPICE stands for Simulation Program with Integrated Circuit and Persist. So SPICE is basically the software, the system, okay, the system that considers simulation of IC. Not only just, as you can see from here, from multisim interface, not only the component like battery, resistor, diode, capacitor, inductor, not only just a simple electronic components, but also we can consider to simulate more advanced component like IC, okay, TTL. Let me just show you the lecture notes, my handwriting. Okay, so this is the, I have already shared this handwriting lecture notes with all of you in WhatsApp group just now. So basically you can refer it as well. Okay, so SPICE stands for Simulation Program with IC, IC emphasis. Okay, so IC, when we talk about IC, it is more advanced component, okay, which is in one single IC, it actually has some other components like transistor, diode, everything is inside. That is why we call it as IC, integrated circuit. Okay, so in IC, sometimes it should have two at least two transistors, for example. Okay, so so there are multiple other components inside that IC. So it is more advanced. TTL is logic circuit, gate circuit gate circuit that do the digital processing, okay, like flip flop, right? So TTL is logic circuit. CMOS is we can also simulate CMOS, which is CMOS stands for complementary metal oxide semiconductor. For example, in SLR camera, right? In digital SLR camera, for example, uh, what makes that DSLR camera expensive is this chip, which is CMOS chip. For example, in uh, your handphone, okay, some handphone got very advanced camera, right? They use advanced CMOS chip for that camera for processing purpose of the image. So CMOS also used in some battery to control the state of charge of the battery, for example, monitoring the battery status, all right. And then also microprocessor, okay, microprocessor like we see in the some microprocessor chips that used in the computer and other electronic appliance, for example, electronic instruments. Okay, so that's all of the other components which is based on IC, integrated circuit. That one belongs to the SPICE simulation. What it means by SPICE? SPICE means consideration in terms of simulating the IC, okay, integrated circuit emphasis. All right, so next, so what is schematic diagram? I think we have already learned this from the beginning, from topic 2, which is basically the schematic drawing is different to the sketch, right? The schematic sketch drawing is much more, we will do it in the using software, which much more proper configuration, proper arrangement of the circuit, which is we can do circuit design using software and then do simulation, which is fully functional thing, which is something like this is the example of the drawing, which is schematic drawing. Okay, working schematic drawing, right? So this is an example of the working schematic drawing, which is something that is quite precise and readable, meaning that for a working schematic drawing, for example, you as a electronics engineer, your work is to design this working schematic drawing so that you can design it. You design your working schematic drawing in such a way which is produce the drawing like this, and then you put your the person who has prepared this drawing, like for example, And as you can see in this slide, drawn by L Hyde, which is the person that has prepared this drawing, and it was approved by somebody who put some initial here, the signature. Okay, the approved person, and then the person who has prepared this. So once you prepare this, which is you prepare something that is understandable, which is clear, which is something is readable, meaning that if you pass this drawing to another person, they can read and understand this drawing. Okay, so that is about working schematic drawing. For example, okay, if you are from one company, automotive industry, for example, you are engineer, which is your job is much more to do the to design, not to design, but more to focus on installation of the shock absorber or whatsoever drive system of the car. Okay, so you're focusing on not drive system, that one is mechanical. Let's say a computer box of the car, right? So you are the person who is in charge for a computer box of a car that you manufacture at the automotive industry, in automotive factory. And then you have the supplier of that computer box of the car, for example. So that supplier is from another company. Okay, so that supplier is another company. So once that supplier is supplying that computer box to you, to your company, then what you're going to do is not only you receive that computer box to install it, but also you will receive this sort of drawing. Okay, so engineers must have the ability to read the drawing. Okay, which is what is inside of the hardware that you receive. Okay, so basically this is an example of the working schematic drawing. So with this simulation software, which is Multisim, we can do simulation, not only a simple simulation, but also advanced simulation. Okay, advanced circuit also we can do simulation using Multisim. But this one is the educational version. I think it will limit us to simulate some nodes. For example, a more complex circuit which has multiple nodes, which is, for example, more than 100 nodes, we cannot simulate, because that one also available in the pro version or full version. So for educational version, they will give us for free, but with eh, limited access to some nodes, for example. Okay, all right. So basically, the multisim, like I have already shared with you on how to install. I hope that you can follow that video on how to install. If you are still fail to install this, try again, try to download it until you successfully download and install in your PC. Okay, so basically the installation process is simple. The one thing that you need to consider is to extend the evaluation version, which is from initially will be given 7 days, and then after that you have to follow some instruction. In this video as well, I have attached the document that you can follow, so that you can further extend your evaluation period up to, I think, more than 40 days lah. Okay, so basically, as you can see, and then as what I can share in this my PC just now is the interface of the multisim. So I have opened this in my computer. I hope that you can also open this in your computer. I don't know how you can open it. If you are following this with if you are have different setup, like you have desktop computer and also laptop, so I think you can follow it. Otherwise, what you need to do, just watch just follow it. Just make sure that you keep watching the demonstration that I'm going to do from my PC. so that after that you can do it at home, right? So this is basically the interface of the multisim. When you open it, it will automatically open with the canvas, the drawing canvas. Here we have which is by default it will name this drawing canvas as design 1. Okay, as design 1. So basically, as you can follow in this lecture slides, all right, in this lecture slides, as you can see, there are some parts, which is number 1 is the menu bar. Okay, number 2 is the design toolbox. This is your design toolbox. So for example, I have the first design here. If I have another design or another file I would like to open, I can open another file, another design, and it will appear here, which is as a tree. As a tree, right, we call it tree. So this is the design toolbox, and the third one is component. The third one is component toolbar, which is I think this one is the most important area that you should know, which is you can access all of the component from here. Okay, you can access all of the component from here. And then number 4 is related to standard toolbar button that contains how you can if you select this means that you want to open the new file. Okay, and the other one, like if you want like to open the existing file, okay, to save the file. Okay, that one is number 4. 5 is more to the view toolbar, right? 5, for example, if I can show you uh, this one, right? If you like to zoom in or zoom out, okay, just in terms of view, all right, in terms of view, I think you can, okay, if you click this, it will return to the standard drawing area. If you like to drag it like this, you can click on your scroll button. Okay, you have left click button, right click button, right, and then the scroll button in the middle. Actually, that scroll button you can click, it will appears hand like this, so that you can drag. For example, if you have some uh, complex design here, of course you would like to go to some other component, right? So maybe you don't have to zoom out, you just can drag it like this, right? You can just drag it like this. So that sort of thing you can do with the zoom in zoom out button. If you want to go back to the standard canvas, okay, just click on this. All right, number 5, 6 is about simulation button, which is this one. The green one is the simulation button. Once you complete drawing your software here, you can just click on this simulation button, which is to run the simulation. So at the moment, I don't have any circuit, so it will appear that simulation error like this. So basically, you can also access this simulation button from simulate. Okay, then basically from simulate, you can go to analyze and simulation. So go to the analyze and simulation. We have all of the analysis in terms of AC analysis, which is small signal analysis, simulation, small signal based simulation, transients, which is large signal simulation, DC sweep. Okay, so for an AC circuit, for example, we can do the DC sweep to find the DC operating point of the circuit. And then some other advanced simulation like Fourier. Okay, Monte Carlo. All right, noise, there are multiple choices of type of simulation you can do in analysis of the circuit. But in this lecture, in this practical lecture, what we will cover is much more to the AC simulation and also the transient simulation. Okay, just these two types of simulation we will explore in this practical lecture. So we have another tab here, which is output tab, and then summary. So basically, for the transient simulation, for example here, what we need to do later is to put the start time and stop time of the simulation, and then the output, what sort of variable or output variable we would like to observe, right? For example, at the output, we would like to observe the output voltage, so we can select the voltage, right? So that is about number 6, which is the button that represents the simulation, which is this one. And then number 7, is more to the main toolbar, which is common multisim function. I'm not sure number 7 is here or not, but basically number 7, I think this one, we can use these buttons, okay, common multisim button, because multisim not only can simulate the circuit, but also we can convert the circuit into multi-board. We call it multi-board, which is the PCB board. Okay, we can convert our circuit into a PCB board, and also we can also transfer this to a breadboard. Okay, I will show you. I will show this to you later at the end of this slide we have that I will demonstrate. All right. So next is number 7, number 8. Number 8, the component list. Okay. Number 8 is the list of the component which you can access from here. For example, if you drag one component, you put one component, okay. So this diode, for example, it will appear in this list. Okay, so all of the components that you use in your circuit will appear in this list, which is the component list here. All right. And then number 8, number 9. Okay. There is another button instead of the standard component button, component button or component tools lah kita panggil lah. Instead of this component tools here, we have another this is not the component tools, but this is more to the measuring equipment. Okay, like for example, the first one, if you move your cursor to the first one, you will see this is the multimeter. Okay, you can place the multimeter, which is represented by XMM number 1. If you put the second multimeter, it's XMM number 2. All right. So we have multimeter and also function generator, which is either we want to generate the sinusoidal function of the wave. Okay, all right. For example, we want to generate a sawtooth wave, triangular wave, any waveform we like to generate. We can use this. Okay, you can use this to generate any functional wave. Okay, functional waveform, not only sine wave or cosine wave, for example, but also any more advanced wave. So we have function generator. For example, this is the sawtooth wave. This is pulse wave, right? This is pulse wave, sawtooth, and then wave sinusoidal waveform. Okay, so that is the function generator, which has more here, which is wattmeter. Wattmeter is it functions as an instrument to measure wattage or power of the circuit. Okay, so power output can be measured using a wattmeter, and this is one of the most common measuring instrument that we are going to use, which is oscilloscope. Okay, So from this oscilloscope, you can measure the output from these two probes. So this one is two probes oscilloscope. We have probe A and probe B. Okay. All right. So next is number 9. Number 10. Number 10 is basically we can move this. Number 10 is scroll left and right, which is if you have a big project, for example, if you zoom in this, you will see this, so that you can move the cursor to see, for example, if you place the component here, so it's quite big. Cancel. So this, we have component here. You can zoom it by scrolling. Move your scroll button. If you move forward, it will zoom in. If you move backward of the scroll button, you will zoom out. So basically, in a big project, in a project full of components, okay, we want to drag this. Okay, we can use this to scroll left and down, okay, up and down, and then left and right. But also, and then also we can use, just as I mentioned just now, you can just click on the middle of the scroll button. You can click on the scroll button so that you can move it like this. Okay, so that is about number 10, which is the scroll bar. And then number 12 is your design. Number 12 is the active tab, right? Number 11, your space, okay, your working space, your workspace, the canvas that you can put the component and do the wirings, connections. And then number 12 is design, design tab. So if you have the multiple design, let's say I want to open my other design here, okay, it will appears my other design next to this design number 1, which is design number 2. Okay, also from design toolbox, also you can access different drawings. All right. Okay, let me just close this one. How do I close this? Okay. Okay. So now I'm moving to my earlier design, which is design 1. Okay, so the sort of thing about the interface. Okay, I hope you can do it at home later or now. Just move your cursor to each of the part. Here you can see some pop-up. From that, for example, this is place the diode. This one is place transistor. Place analog component, TTL, logic circuit component, CMOS. All right. And then some other components simulate here, which is run, or you can just push F5 from here. Okay, so so that is the introduction about the interface. Okay, the interface, the introduction of the components, components toolbar that you can use during your simulation. This is another explanation about the component bar. Okay, we have here. So this is basically the most frequently used part in this simulation software, which is maybe you would like to access the source, which is battery, the AC source, for example. This is the button that you can access the source. Okay, and then the basic tools, which is for example resistor, capacitor, transistor, inductor. Okay, you can access this from here. And then diode component, any types of diode component you can click on here. then transistor component, analog component, and so on. So basically, the thing is, if you just click any of this component, for example, let me just click on this any component. Let's say I click on diode, so it will appear this pop-up, which is select a component. Okay, so basically from this interface, as you can see, so when I click diode, it will by default go to diode family. Okay, as you can see in this group. Okay, so it appears here diode group. So as you can see below here, they are all the component that belongs to diode. All right, we have some Zener diode here, then several types of Zener diode. Okay, the photodiode that I have given to you for your mini project, right? That one is photodiode. Okay, so we have many types of photodiode. Okay, many types of photodiode, you can access it from here. And also SCR, silicon control rectifier, LED also available here. The green, this is bar LED, normal LED. Okay, the green color LED. The one that I gave you is white color LED, right? It's white color LED, blue, green. This one is infrared LED, which is the black one that I gave for your mini project. The black one is the IR LED, right? So you can select IR LED to construct your circuit later. Okay, so when you open this, basically you can also open other family, other group of component, like basic component also you can access this from here. So not necessary you have to close this and then open the basic component back again. So you will be back to the same library. All right, so basically the tip is you should know what group belongs to that component. For example, so we have basic source component, basic component, diode component, transistor, analog, TTL, CMOS, and so and so on. So we have many more like radio frequency component also available here. Some other connectors. All right. Okay. So once you select that component, for example, the diode, you might be select some what type of diode. Okay. What? Let's say if you like to, if you select this LED, you will see what type of LED you would like to choose as your component. For example, you select this one. This is the bar LED of yellow, the yellow bar LED. Then just close this. Then you can do the arrangement of the component. Okay, so okay, the first thing we are going to do in this practical lecture, the first circuit that we are going to construct is this simple circuit, which is called as the voltage divider circuit. So we are going to construct this voltage divider circuit using multisim. Okay, as you can see, this is the circuit that has been constructed before. So what we're going to do today is I'm going to show you on how you can select all of these components. We have 3 components, 4 inclusive of the grounding here. Okay, 1 2 3 4 components we have here. And then we next is we are going to connect all of these components. Okay, from positive terminal of the battery, you will be connected this one to one part of the resistor, and then from this resistor we are going to connect to one part of the potentiometer. Okay, this is the potentiometer, then the ground, then back to the voltage source. So we are going to construct this. Let me just put this at the side of this screen. Okay, so we will start with placing this component, which is battery. All right, So I'm gonna put this battery component. Just make sure that you click any button is fine, but we have the place source here. You can just click on place source. Okay, so it will appear the library like this. Now we are going to place source, which is the DC source. Okay, so we will find the DC source. So another tips that you can follow is, if you know that you want to place the DC source, just type the DC source. Let's say I type DC here at the component search bar here. At the component search area, it will appear 4 types of DC source, which is DC current, DC interactive current, DC interactive voltage, DC power. So what we are going to place is DC power source, which is something that looks like this, which is the 12 volt like this, right? So by default, click on this and then left click to place the component. After you left click, you place the component, it will appears again the library, meaning that it asks you to place another component. Okay, so next is we want to place resistor component. So for the resistor component, just search it in the group. So resistor is basically belongs to basic group. All right, so we click on basic group, then we find resistor. Okay, we find resistor is here, right? So click on resistor, it will appears different rating of the resistor. Okay, so for this resistor, we want to place 1 kilo ohm resistor. So just find the 1 kilo ohm resistor in the list, then click OK. Then you will place the resistor to the appropriate place, which is maybe around here. Okay, so I have already put source and resistor, which is 12 volt source, which is the same to this one, and also the resistor 1 kilo ohm. And another source, another component is, which is looks something like this. So basically this is the voltage divider component. So we call this as potentiometer or variable resistor, or this one is much more to the potentiometer. Okay, so it belongs to the group of basic group. Okay, but this one is not resistor, but it is the potentiometer. I will explain to you what is the difference between potentiometer and variable resistor. So we have the variable resistor as well, but we are not going to place this one because, as you can see in this figure, this is actually the potentiometer. But actually, variable resistor, potentiometer can function like variable resistor. I will explain it later. All right. So basically, we place this component, which is the potentiometer. If you like to rotate this component, by default it will be like this. Okay, if you like to rotate, just Control R, so the component will rotate. Okay, Control R, the component will rotate about 90 degree. Okay, 90-degree rotation like that. So once you finish rotating, then just place it somewhere on your canvas. Okay, so I have already placed the resistor. Then finally, I want to put the grounding, which is the returning point of the current. All right, which is the common ground. Where's my common ground? Let's search it. Otherwise, you can just search it from here, GND. If you couldn't find it in component search, click on all family, and then find the grounding, GND. Oops, basic, all groups. Okay, all groups, then find the GND. Okay, so you can just specify this group to all groups. All right, all groups. If you don't know the grounding is belongs to which group, just if you don't know any component, we don't know that component belongs to which group, you don't know, then you can just select all group here, and then search in the component bar, the component search bar, which is grounding, GRO, then it will appears ground, then you can select this. So now place the ground somewhere here. Okay, so we have already placed all of the component. Okay, which is we can complete this divider circuit, the voltage divider circuit here. Now we don't want this, library to appear again. Just click on close, right? Then we can start do the wiring. All right, so before I do the wiring, let me just explain a little bit about the difference between a potentiometer and then the variable resistor, as you can see in the handwriting notes here. So in terms of symbol, it is different, which is this is the symbol of variable resistor. The other one is the symbol of potentiometer. It has wiper in the middle. All right, so basically this potentiometer can become the variable resistor if we connect wiper and the other end. Okay, let's say this is the 1 kilo ohm terminal of this potentiometer, then we can connect this 1 kilo ohm terminal and also the wiper terminal, which is similar to this figure, which is I connect wiper and also the other end of the potentiometer. All right, so basically we can use this potentiometer to use it as a variable resistor. Okay, and the other name for variable resistor is rheostat, right? Okay, so potentiometer is also known as a voltage divider component. So this is a special component that is used in voltage divider. We call it as potentiometer. The one that I gave you, which is this component. All right, this component is, I've given not all of you, but you can watch it from here. All right, so this is the potentiometer where it has the dialer. The dialer where you can we rotate this to adjust the resistivity of this potentiometer. Okay, so it has three terminals here, which is wiper is the one in the middle. Okay, so to test this resistivity of the potentiometer, you can use multimeter. Right, you can use multimeter, then try to connect it to middle and to the other end. Then you will see when you change this, the resistivity will change. All right, so this is basically the component that we use to adjust. For example, we want to adjust the sensitivity when we want to adjust the voltage. For example, like this one, the voltage divider, we want to adjust the voltage supplied to other component. Okay, for example, you want to adjust the voltage supplied to photodiode, right? So we can just change this, adjust this, meaning that for example, in the application of sensor, we can do this adjustment to adjust the sensitivity of the sensors. All right, okay, I hope you can get this, can get it. So next is I'm going to place the wiring. So to do the wiring in Multisim is simple. not like LT-Spice. In LT-Spice, I have to click on one of the component, which is wiring component. But for the Multisim, you just move the cursor, move your cursor to the point, which is one of the terminal of the battery. I move this cursor, then click. So you can do the wiring like that. And if you like to connect to another component, when you reach one of the terminal of the resistor, for example here, just click. So it will automatically appear a wire like this, the right one here. So meaning that I have already do the connection between the terminal of the battery and then the resistor. All right. Next is you can do the same thing. Connect this to this or to this. So basically, we want to make this potentiometer like to work like a variable resistor. Then we connect to the wiper. All right. Connect to the wiper. And then from the other terminal of the potentiometer, we must make sure that it is connected to the grounding first. And then from the other part of the battery, then we make a loop. We make a complete circuit. Okay, so we have made a complete circuit of our voltage divider, which connects this wiring. The right one is connected to each of the component to make sure this circuit is complete. Okay, so we finish that part. So this is another explanation here. If you cannot follow this demonstration, lab demonstration or software demonstration synchronously, I mean in live, you can follow this later by following these slides. You can do it at home later. Either you want to check on this slide, follow this slide or the video that is recorded. So basically, uh, when you go to this slide, the next slide to the circuit. Where's my circuit? So this circuit, basically, it is also explained here on how you can place all of the component like I have explained it before. Okay, which is you can follow this procedure to construct the previous circuit based on this explanation. And then once we finish construct this circuit, now what I am going to do is to connect the multimeter. Okay, since this is the voltage divider circuit, I want to use the multimeter to measure the input and output, to measure the output. Okay, the output across R1 and also the output across R2. Okay, so what I'm going to do now is to use two multimeters. Okay, just select the multimeter here. Okay, just select the multimeter. So this is the multimeter that we are going to measure the voltage across R1. So take that one of the positive probe of that multimeter, connect it to one terminal of the resistor, and connect another probe to another terminal of the resistor. All right. So you can always move this. If you don't like the arrangement of the wire like that, you can just move it like that. No problem. Since it is already connected, no problem. No problem. Right. So it turns it like okay. Let me just do it like this. Okay. So I have already connected both probe of multimeter to across this R1, right? Then I'm going to put another multimeter across R2. Okay. This is the way how we use the multimeter to measure voltage. So I'm going to measure voltage using this multimeter. For example, this is the multimeter. So I have these two probes of this multimeter, right? Okay, so I have this multimeter, two probes, the red one and the black one. Basically, the red one will be connected to the positive terminal, which is the live terminal, and then the black one will be connected to the grounding or the common terminal, right? So when we use the multimeter, we have two probes. So when we want to measure the voltage, make sure that we connect the other terminal to the multimeter to the voltage part. All right. So for example, if this one previously it was connected to the resistor, okay, capacitor. Now I'm going to move this red one to volt. Okay. So make sure this probe is connected to the volt if we want to measure voltage. All right. So positive probe must be connected to the probe which is shows V, which is voltage. So we have placed this multimeter and then the other multimeter here to measure the voltage. Now we have already done component placement, wirings, and also measuring instrument. All right. So once we finish this, okay, of course, next step is we would like to do the simulation. So with the default setup, we supply 12 volt, all right, to 1 kilo ohm resistor, and the other one is 50% of 1 kilo ohm, which is 500 ohms, right, or 0.5 kilo ohm. So this is half, right? This is half. This is 1 kilo. This is 500 ohm. So we want to measure voltage across this. So just click on run or F5, then simulate. So when you click the simulate, it will continuously do the simulation. It won't stop until you stop it. Okay. So once you click on simulation, make sure you pause or stop it. All right. Just stop. Then basically we have already got the output from this multimeter. Okay. If you like to see the output, just double click on the output on the multimeter. Then you will see the display of this multimeter, which is 8 volt here, and another display of the second multimeter, which is 4 volt. Why is this 8 volt? Why it is 4 volt? Can I ask somebody? We have 3 o'clock. Another 1 hour to finish. Okay. All right. So why is this 8 volt? Why this is 4 volt? Because this one is the value of the resistor is half. Okay. The value of this resistor is full, which is 1 kilo. This one is 0.5 kilo because it is 5%. If I make this 100%, meaning that this resistor is now 1 kilo as well. So if I do click on simulation again, you will see the voltage divider is now divided into half. Okay, 6 volt across here, another 6 volt across here, because this resistor is now 100%, which is 1 kilo. Okay, so you can just play around at home. Okay, you can just play around now by dragging this value of the resistance, which is for example 20%. What about 20% of R2? 20% means that 200 ohms, right? So meaning that you have changed the resistivity of this R2 to 200 ohms. Okay, so that sort of thing, you can use this dialer to adjust or to change the sensitivity of this resistor, which is it functions like the dialer that I've shown to you for this potentiometer. We have the dialer here. We just can rotate this to adjust the resistivity of the resistor to, for example, in some application, we would like to adjust this to adjust the change the sensitivity. Okay, sensitivity of the sensors. we want to adjust the amplification of when we use this for amplifier. We want to make the output of the voltage bigger or smaller. We can adjust this. All right. So basically in voltage divider, let me just show you the lecture notes that I have shared with you. Here some analytical explanation in terms of calculation. I have already shared with you, given to you the calculation about so you can see this is the voltage divider circuit that we have simulated just now. All right, then another process which is we want to simulate and then observe the results. So this is another explanation, okay, in terms of circuit, which is V total voltage 12 volt here is actually the sum of V1 and V2, which is V1 across R1, V2 is voltage across R2. Okay, so next is this is the example of the calculation. Okay, in terms of calculation, you will have a look at that, something like this. So for voltage divider at V1, basically we already know V total voltage. So we do it like this. So this is basically the analytical approach, which is the calculation based approach to calculate the voltage across these resistors using this expression. All right, so what happened when we change to 20%? Either you can do the simulation, we do simulation again and then check on the voltage. When we change this to 20%, we have 10 volt at the R1 across R1 and 2 volt across R2. Okay, so we can conclude that the total voltage here is equals to the voltage here plus the voltage here, which is the voltage across R1 plus voltage across R2. So that sort of thing on the explanation about our first circuit. All right, so now we are going to move on. We move on to RC filter using AC analysis. All right, so make sure that once you finish your work, okay, make sure that you keep save. Remember to save your project, your circuit in any folder you like to save it. So let's say I'm going to save this. So I'm going to click on simulation is still running, so I have to stop this. Okay, so I'm going to save it to somewhere, save as. If you like to rename it, just rename it. Okay, so go to the your working directory or whatsoever folder you have set up. Multisim practical 2020 model. So this, just save it as design by default design1.ms14. Okay, and then click save. So since I already saved one, so I don't need. Okay, so remember to save this to your folder. All right, we are going to move on next net circuit, which is in this case we are going to use RC circuit. Okay, we open open another another workspace, which is design2.ms14. Okay, open another workspace like this. We are going to sketch this circuit now. Okay, so just follow this slide. All right, so we are going to draw this RC filter circuit. Okay, RC filter circuit with supply voltage of AC voltage. We have current we have resistor of 1 kilo ohms, all right, and then the capacitor of 100 nanofarad. Okay, so try do the same thing that I have shown you before. Okay, basically we are going to place this source and then R1 component and also C1 component and then also the ground, right? Then we are going to measure this using oscilloscope. All right, so basically just follow this slide to simulate the circuit that I've shown you. Okay, and then these settings as well. Okay, these settings, and then we can simulate this graph. Okay, the output of the RC filter. Okay, let me just show you one by one. Okay, basically we want to place the source. All right, so I just click on source. Now I'm going to place the DC, not DC but AC power source, right? So just click on AC power source. Okay, place that source. Then next is we're going to place the resistor. Find the resistor, basic component, go to the resistor, and then what is the value? 1 kilo ohms. Okay, by default is 1k. Put the 1k resistor. All right, and then another one is 100 nanofarad capacitor. So capacitor belongs to which group? Capacitor also belongs to basic group. Then find the capacitor. So this is the capacitor, which is 100 nanofarad. So find the value of 100 nanofarad. This is micro. I don't want the micro. I want the nanofarad one, which is N. All right, 100 nanofarad. Let me just search this 100. So this is 100 pico. I want the 100 nanofarad, which is this one. Okay. So now my capacitor is horizontal. I'm going to rotate this vertically, which is like this. Okay, I have push on Control R to rotate this. Place this component. Then another one is grounding. So we have ground here. Place the ground. Then finish. So we place all 4 components on the canvas. Now make sure that the value of each component is correct, which is V1 120 VRMS, 60 Hertz of frequency, 0 degree of angle, and then 1 kilo ohm resistor. Just double check the component values. 100 nanofarad of C1. Okay, next is do the wirings as usual. Connect each of the terminal to wire all of the components, then complete the circuit like that. So I have finished drawing this circuit, which is RC filter circuit, okay, with AC source here. All right, now I'm gonna place the oscilloscope. Is this the oscilloscope? No, this is not the component of oscilloscope. That one is generator, right? Function generator. I'm gonna place the oscilloscope, which is this one. Okay, so select the oscilloscope, put it somewhere. Okay, now oscilloscope is different to multimeter. Okay, for example, for this oscilloscope we have 2 terminal, which is A terminal, A probe, then B probe. All right, for each A and B it has plus and minus. Okay, so it has plus and minus for A, plus and minus terminal for B. So let's say in this RC circuit, I am going to measure the input voltage, input signal, okay, which is I connect positive terminal of A to here, okay, and then negative terminal of A to ground. Make sure that when you use the when we use the oscilloscope, the black one or negative one always should be connected to the ground. All right, so for this case, negative one, I will connect this to the ground, which is the common terminal of the ground. Similarly, for B, okay, for B now I'm going to measure the output across capacitor, output signal, okay. So I will connect somewhere at the one terminal of the capacitor, and the other one, as usual, I will connect it to the ground, right? So make sure that negative terminal is always connected to the ground, okay. But for signal B, we want to measure the output signal across capacitor. For signal A, we want to measure the input signal, which is from the source. All right. So that's all of the connection. All right. So we have done this connection for our circuit. As usual, save as. Make sure that you save as to any folder that you like to. Then by default, just save as to design2.ms14, right? So I have already saved it before, so I don't need to click on save. But for you guys, you need to save it. Okay, next is to do the simulation. All right. So make sure when you do the simulation, now we are going to use the AC simulation, which is AC sweep. So if you follow these slides, you can do it, which is I'm going to set the simulation settings to go to the simulate and analyze and simulation. Okay, so it will appear the active analysis pop up like this. So we just select the AC sweep. Okay, select the AC sweep, which is you can follow this. You can follow this part of the slide, which is the setting is here. All right. So in AC sweep, we are going to do the simulation. We're going to set up the frequency parameters of which is this one, which is start frequency of we are going to measure the frequency, the output frequency from 10 hertz to 1 megahertz, to 1 megahertz. All right, which is similar to this what it appears in the slides, 1 megahertz. Then we specify this on decade, which is every 10 sweep, and then number of decade, of course, which is decade means 10, right? Then put this as not logarithmic but decibel. Okay, put this as decibel. So we have specified this. Then the output. So now at the output, we are going to measure V1 and V2. Okay, just add V1 and V2. All right, so we have specified all of the simulation variables. This is sweet. Then just click run. So what we see, what we can see from our simulation here is this simulation, this output from our oscilloscope. As you can see, the top one is the magnitude. Okay, magnitude in terms of decibel versus frequency range. Okay, axis is frequency range, and the bottom graph is phase plot. All right, so this is the phase plot, which is in degree. So I'm not going to discuss further on phase plot. Just focus on this magnitude plot. All right, so as you can see, we get the same magnitude plot here. All right, so this is the grapher view. You can always change the view of the results here based on the grapher view. You can zoom in, zoom out. Okay, then back to the normal like this. So just use the lines, and you can explore some other features, some other buttons here you can use. You can also change this uh, lines also. All right, for example, I'm going to change this to orange. Okay, it is already changed to orange. So the color, so traces, you can always modify the way how it looks, in terms of graph that you have here. All right, so we have this, which is actually, this is the uh, it is already explained in the notes here. You can also refer to this note. It is already explained here. This is the AC sweep analysis for an RC circuit. Okay, we have the RC circuit here. We do the AC analysis. We specify the frequency, which is start from 10 to 1 megahertz. Okay, for the X axis, and then we specify all of the simulation in the analysis and simulation tab. Then we select the variable. Right, with the variable we have to display in the output. For example, the red one is the output for input. Sorry, the red one is the signal for input, right? The green one is the signal for output, which is for this probe. All right, the red one is the signal from this probe. Okay, input. So red one is input. So at the input there is no change. Okay, which is in terms of RC circuit, basically we want to see the filter effects. Filter effect, for example, we have this sort of signal. We want to block some frequencies. Okay, we want to block, which is, for example, in this case, the frequencies above 1 kilohertz will be blocked. All right, okay, so frequencies above 1 kilohertz will be blocked, which is filtered by this capacitor. So we will not allow the signal over than 1 kilohertz. All right, so this is the function of the uh, RC filter. So this is low pass filter, meaning that we only allow lower signal. All right, lower frequency signal. The higher frequency signal we will block. We'll block it. Okay, some question here. We can observe what is the x-axis range. So x-axis range is the frequency range. Y-axis range is decibel, which is magnitude range. How are the input and output signals look like? Which is looks like this. The output is it has some knee point here, and then uh, straight goes to the zero, which is some frequencies has been blocked for the output. For the input, it remains constant. All right, and then play around with grapher view. So this is another explanation, which is this is low frequency part, this is high frequency part. Okay, so this is the low pass filter, which is high frequency signals are blocked. As you can see, most of the signals over 1000 hertz has been blocked. And then some explanation about what does this mean by decibel. Okay, decibel means gain. So we can determine voltage gain in decibel for any sinusoidal input within the given frequency range. For example, in the given frequency range of 10 to 1 megahertz here, we can determine the sinusoidal input and output of the frequency of the signal. All right, in decibel. All right, so in this case, input is red one, output is the green one. So this is another definition of decibel, which is 1/10 of bell, right? So if you Google this as well, you can find, which is decibel means 1/10 of bell, which is the relative measurement corresponding to 1/10 of a bell. All right. So basically, we use this equation for the decibel. So we use this equation for the decibel, and this is the gain, decimal gain, meaning that this gain is basically refers to the signal of output divided by input. All right. So using this equation, let's say 0 decibel, which is 0 decibel here. 0 decibel means that if we compare the output voltage to input voltage, it is the same. Okay, meaning that at 0 decibel, output and input ratio is the same. All right, which is 1. The ratio of output and input is 1, which is in log. We can just calculate this. We can get the 0 decibel. So 0 decibel means output and input is the same, meaning that the input voltage will be the same as the output voltage. As you can see the red lines here, the red output, the red signal, this one is the signal for 0 decibel. All right. So there is no change in terms of output and input. How about -3 decibel? Okay, so this is example calculation of the -3 decibel, which is using the same equation here. Using this equation, okay, using this equation, we can calculate for -3 decibel, which is the ratio of voltage output to the voltage input is 0.7071, which is in this case is less than 1. What does it mean by less than 1? It means that the voltage output is smaller than the voltage input. Okay, because V out is because V out divided by V in, right? So when V out is smaller than V in, meaning that we get less than 1. Okay, that is what it means by negative. Okay, negative uh, negative magnitude, which is in terms of decibel. So -3 decibel signal. So when we calculation this, so when we take the negative decibel, so for multisim, we cannot do some specific coordinate tracing here. Unlike the LT spice, we can do it, but for multisim we cannot. So just assume that -3 decibel, which is around here. So when we plot the output, it will around some more than 1000 hertz. All right, that reflect to -3 decibel. So let me just see this. And then the calculation of -3 decibel means that 0.5 watt of power, which is half the output. In terms of power, since this has been filtered, the initial power, which is for example 1 watt, has been reduced to 0.5 watt. Okay, in terms of power. So we have another example here. Example calculation, you can refer to this one. Let's say we have output of 24, input is 12, which is 2 times. So this one is 6 decibel. So that is the calculation. Now, there is a question we would like to analyze here. Okay, at what gain in decibel is the output signal is 10 times smaller than the input signal? Okay, let's say in what gains in decibel is the output signal. The green one is 10 times smaller than the red one. Okay, so that sort of thing that we like to analyze. Let's say we use this equation, decibel equation here. We know that in this part, supposed to be V out divided by V in. Let's say I'm gonna put the output as 1 the input as 1, so means that 10 times smaller of the output, it's actually 0.1 lah. All right, so we have V out of 0.1, V in as 1. Okay, we do the calculation based on this equation. So we get negative 20 decibel, meaning that to answer this, which is what gain is the output signal is 10 times smaller than the input signal. Okay, 10 times smaller means negative 20 decibel of gain. Okay, negative 20 decibel of gain, meaning that we have the filter circuit here. So we have the filter circuit here. Then we plot this circuit like this. So if we try to trace the negative 20 decibel, it will go to the somewhere around here, somewhere at this point. Okay, the output, which is in this case, we cannot clearly identify this because we are using multisim. We cannot do this. If we use the LT-Spice, later I will show you the same simulation that we can trace at negative 20 is actually 16 kilohertz. Okay, so as I mentioned, it is actually 16 kilohertz. All right, when we plot when the signal is 10 times, the output signal is 10 times smaller than the input signal, that means the magnitude is negative 20 decibel. All right, so if we trace what is the frequency of that signal at negative 20 decibel, okay, we can trace from this graph, which is 16 kilohertz, which is somewhere around here. Okay, so this 16 kilohertz, basically we can confirm it, which is actually we can further analyze this circuit. All right, we can further analyze this circuit using the transient analysis. Okay, we use the transient analysis to resimulate this using transient analysis to confirm whether is it correct or not that negative 20 decibel is 16 kilohertz. All right, for the case of the output is 10 times smaller than the input. All right, so in this case we do the simulation again, which is we are going to do the transient analysis. Okay, I'm going to do the transient analysis. So as you can see in this slide, how do we validate how do we validate that 20 decibel correspond to negative 16 kilohertz? No, so now let's do the transient simulation using the same circuit. So what I'm going to do is make sure that you always save this. So since I'm going to do the different simulation, which is the transient simulation for this circuit, what you should do is to save as this to design3.ms14. Okay, save this to design3.ms14. So I have already done it in my previous simulation. So let me just open that. Let me just open my simulation circuit that I've done before. Sorry. Practical lecture on software, multisim practical, model. Okay. So we construct, we use the same circuit, but we adjust the simulation, analyze and simulation here. We change this to from AC sweep to transient. Okay, we change this from AC sweep to transient. All right, so we set all of these simulation characteristics from 0 start frequency to 0.01, which is 1 millisecond, 10 millisecond, right? So we set this from 0 to 10 millisecond. of the transient analysis. Okay, so transient will start from 0 to about 10 millisecond, and then how about the output? We still measure the same output, which is V1 and V2. All right, so there is no much change in terms of uh, simulation settings, right? Basically, we just want to change the T start and T stop, which is 0 and 0.01. Okay, but for this case, since we would like to do the transient simulation, we want to confirm that 16 kilohertz is correct or not. So what we specify for this source, okay, let's say I want to uh, change the input signal of 1. Okay, as you can see in this lecture notes. All right, as you can see in your lecture notes, the handwriting lecture notes here, as you can see it. So I have made some explanation here. We want to put the input signal of 1 volt sinusoidal signal, okay, and then the frequency we set it to 16 kilohertz, which is when we plot in our AC analysis just now, 16 kilohertz is correspond to the negative 20 decibel, which is 10 times smaller of the output signal to the input signal, meaning that output signal is 10 times smaller than the input signal. Let's say if we put the input signal of 1 magnitude, meaning that the output signal must be 0.1, which is 10 times smaller. All right, so as you can see for my sketch here, the red one is input, the green one is the output. Okay, so we are going to simulate this to confirm that 16 kilohertz is correspond to the signal input of, sorry, correspond to the signal of negative 20 decibel. All right, so we specify this 16 kilohertz for source frequency, and AC analysis magnitude we set to 1, and voltage in RMS. Okay, so basically in electrical or electronic, I think students of electrical or electronics should know, already know that how to calculate this RMS value, right? So basically RMS value is different to the peak value. Okay, so if we specify the peak value of 1, okay, for the input signal, if we specify the peak value Vp is 1, so to get the RMS value of the root mean square value of the voltage, you just can use this equation, which is Vrms equals to Vp divided by square root of 2, right? So we get this, which is 0.07071. All right. So we just put RMS voltage of 0701. Okay. Dot 0701 volt. Then click OK. So we have specified the input signal of magnitude 1. So we want to check the output. All right. So just do the simulation with the settings that we have done before. As you can see, we get it like this, something like this. Okay. We cannot clearly see from this signal because as you can see, there is red signal and green signal, right? So red signal is input, green signal is output. But we know that the red signal input is larger than the output, right? Because some of the frequencies has been filtered. Okay, so output must be smaller than the input signal. So as you can see, you can you can drag it like this to zoom in your graph. All right, you can further zoom in your graph. As you can see, okay, the input signal, which is the peak of the input signal here, is about 1. All right, about 1 volt. And then the peak of the output signal, the green one, is 0.1. All right, so if, as you can see this clearly, if you just drag this again, if you just, right, let me just, okay, if you drag this again, check this out. All right, the peak of the green signal is actually 0.1. So meaning that we input the signal uh, at 1 magnitude, okay, we get the output at 0.1 magnitude, which is 10 times smaller. Okay, this green signal is 10 times smaller than the red signal, which is input. Okay, so this is input signal, this is the output signal, right? Smaller one. Okay, so that sort of thing we like to confirm that with this 16 kilohertz correspond to negative 20 decibel, which is 10 times smaller of the output signal compared to the input signal. So we can confirm it by using transient analysis. All right, so when we do the transient analysis, it proved to us that the output signal is 1, the input signal is 0.1. Sorry, the input signal is 1, the output signal is 0.1. All right, so that is about the transient analysis. As you can see in this slide as well, you can do it at home later. Okay, then you can follow the video recorded from this session. Also, you can follow this slide, lecture slide. All right, you can do it at home. So basically, finally, all right, we have another 13 or 12 minutes. Okay, finally, you can convert this circuit into the breadboard interface. Okay, so how to do this? Basically, we can do the transfer. Where is you can click on view breadboard. Okay, in these tools, all right, at the top here, you can click on view breadboard, which is this one. If you click this, then it will take some time to convert this into the breadboard interface like this. All right, so we have the component of capacitor. You can just drag this capacitor, place it on the breadboard. All right, so then we have, what is this? This is another component. This is voltage source. Basically, I don't know why is this voltage source looks like this. Basically, this is not voltage source, but basically for the component, you can just place it like this and do the wirings. Okay, so another feature of multisim, you can convert your circuit into breadboard interface like this. But I don't like this. I prefer freezing rather than the multisim. I don't I don't like the interface of multisim. It makes your works very hard to do, right? As you can see from my PC now, uh, it is quite I don't know, the interface is designed in such a way that which is I'm not really like uh, something that I don't like. I don't prefer, which is the interface that looks like this. All right, I prefer using freezing rather than using this. So basically, what Multisim is going to tell us is they also can convert the components that we have already designed from our design. We can convert it into breadboard interface so that we can also design the breadboard uh, drawing. Okay, something like this. All right. Another thing I don't like using multisim is when once you click the breadboard view, it will make your software like heavy. All right, it will make your multisim like heavy, so it's consume a lot of processing, right? So I don't like it. So basically, I'm not recommend you to use that breadboard interface in the multisim to simulate your breadboard circuit. Okay, so basically I would prefer you to use the freezing rather than this one, or other softwares like Easy EDA or other software available in the Tinkercad also can do this. All right, Tinkercad. So basically, from this also using multisim, another advantage of the multisim is other than the breadboard design, you can also convert this to the multiboard. Transfer, you click on this, which is transfer to multiboard. Sorry. Grapher, view breadboard, spice, netlist viewer, transfer to multiboard, which is this one. No. No. Not this one. There is another button that you can click to transfer it to multiboard. I'm not so sure which one is that. So this is the video that shows how you can convert to multiboard. This is the video. You can watch this later. So basically, you can click somewhere, post processor, split transfer, transfer to multiboard. Export, not sure this one. File. I think this one. You have to save this first. No, cannot. Not this one. So my software becomes heavy now because I opened this. Let me just close this. So basically, you can transfer this circuit into the multiboard. All right. So we are not going to cover all of this because in this practical lecture one, we only cover on the analysis in terms of AC sweep and also transient, right? For the multiboard and breadboard, we are going to cover in this session. So to learn more about how to convert the circuit into the multiboard, okay, which is something that looks like this. Okay, you can follow this YouTube video on how you can further convert your circuit design into something like this, which is much more a pictorial based image like this, and also the circuit in terms of the prototype in terms of PCB. All right. So as you can see here, you can place. There is from here you can see that some guidelines where you can place your LED. Okay, some transistor here. All right. So you can do the tracing of the uh, circuit tracing, something like this. Okay, so you can design something which much more proper, which looks like a proper PCB like this using the multiboard. All right, that sort of thing about about multisim, which is firstly we can do the simulation, normal simulation, what like I was doing just now, which is construct the circuit and then do simulation. We can select many types of simulation, including transient and AC analysis. What has been covered in this case is only the AC analysis and transient analysis. And so the advantage of this software is basically we can convert our circuit into uh, breadboard design like this, and also the multiboard design like this. I think that's all of the things that I would like to cover in this practical lecture 1 related to multisim. Okay, so I hope that you can use this software, or maybe not only limited to this software, or also other software like LT-Spice, Multisim, or any other online software that you can use to re-simulate or reconstruct the circuit that I've given to you in mini project 1, which is the line follower robot circuit, so that you can study more about the design of your line follow robot in terms of circuit analysis, for example. Right. So for this session, let me just stop up to this time, which is 3:56. So we finish up to this time to allow some of you to log in into another class. All right. So if you have any question, you can ask now. You can ask me now. Is there any question from you guys? Ada soalan? So basically, if you refer to your WhatsApp group, all right, you can download the lecture notes that I have shared with you. And also, just now I have submitted the pool, which is this is the result of pool. So still most of you, not most, but Multisim 31%, all right. LT-Spice also 31% managed to install. AutoCAD is about 40% of the students. FreeZing is progressing. I hope you can install at least FreeZing. Okay? At least FreeZing you can install it at home, in your PC, in your computer, not in your cell phone because cell phone is Android. So in Windows-based PC, make sure that you can install FreeZing so that we can use it later for assessment. So, but I'm still considering the way how I can design the question for you to answer. Basically, if you don't have software, how can I design the software that you like to do simulation, for example? So in that case, I'm going to think a different way of designing my question. Okay. So from time to time, I will post again this next week. Make sure that you keep trying to install Multisim, LT-Spice, and the other softwares to your computer. All right. So I will keep monitoring on this. So any question? Any question from the floor? Yeah.
Ada soalan yaitu masa yang I receive kan dia kurang satu pair punya diode kan.
Yes. Siapa ni Eng ah?
Kita boleh ya. Kita boleh beli dekat DIY tak?
Electronic component dekat DIY tak ada. Kalau you daripada mana? Penang ah?
Ya.
Penang ada Cytron Technologies, tapi Cytron pun dia ada online punya tu lah. So basically the easiest way for you to get is from online stores lah. I would suggest you to do that. Because if you want to visit the physical shop, I don't know exactly in the Penang, but in KL they have in Jalan Pasar got shop that selling those components lah. Kalau in Penang, I'm not sure. So kalau kat DIY, of course DIY tak ada jual. Sebab dia IR sensor. Kalau LED mungkin ada. So I'm so sorry, I forgot to include that because I have given different instruction to the lab science officer, lab officer lah, science officer lab. So I only gave you one pair, right? Same to the other one. Siapa? Ammar ke Azim? Faiz, right? Faiz only got one pair also. So Eng and Faiz, what I can suggest you now is to find it from online stores. Make sure you construct it first, just one part of your sensor. Construct one part. Sometimes when during your experiment you will burn some component, for example. Then if you want to order it, you can order it all together. Okay, so make sure that you try construct first the first sensor part, the first module of the sensor. Then if it is successfully you manage to run it, then test it, then you have to find another two pieces of LED lah, that IR LED and also the photodiode lah.
Okay.
I hope the other members in the same group make sure that you help Eng. Don't just let Eng do it by himself. All right. Make sure others in the group try to help. Okay. At least you can order it or whatever lah. Okay. So I hope you can share the resource in terms of cost, in terms of doing the project. Make sure that you do it in group, not just let the individual do it. All right. Okay. So Faiz ada nak tanya. Faiz pun dapat benda yang sama. Any more question?
So far for now tak ada lagi.
Okay.
Doctor, for the color LED is not important, right?
What?
The colored LED, it's optional, right?
The color of LED is optional, but
Okay.
I think you better choose the white one, the bright one.
Okay. But if we don't use it, okay, right?
If you okay, yes, it's free to choose.
Okay.
If you like to put another component like buzzer, all right, you can put it. No problem.
Yeah. Yeah. Okay.
It depends on your creativity.
Yeah.
But make sure it is functioning as a line follower. All right.
Yeah. Yeah.
So any more question?
Doktor nak QR code.
Nak QR code. Sekejap. So the consumable that I can supply you only the consumable that support one construction of one line follower robot. But I also like to suggest another member to construct the same thing, which is you can macam mana pakat-pakat lah. Okay, kumpulkan duit, collect some money from others, give it to the leader. For example, the leader can order another component, then do it another pieces of line follower robot. Not only just let somebody do it one. Mana ni? QR. Sekejap, saya share sekejap lagi lah. So sambil saya share tu, so ada soalan lagi tak? Kalau tak ada, is there any more question? If not, then we can just finish up to this stage. Yeah, let me just stop this recorder first.